Hi, I'm Tanisha and you're watching this video with justtutors.com. Today we are going to learn about playing with numbers. In this video, we'll first of all work with some letters for digits and then we'll work on some tests of divisibility. Before we move on to the topic, let us try some warm-up questions first. If you want to try the questions by yourself, you can pause the video and match your answers later. Question number 1. Identify the numbers. So the first number is 21, which is a whole number, and the next number is 2.11111, which is a decimal number, of course, though this is a recurring decimal. And the next number is 8.9, which is again a decimal number. Let's come to question number 2. Write the following numbers in generalized form. First number is 52, so the generalized form for this number is going to be 10 times 5 add 2. This is how we can write down the numbers in generalized forms. Likewise, we can try the same for the next number there. 10 times 2 add 6. This will be the generalized form for 26. Then let's come to question number 3. Divide the given number by 3. And the answer for this is going to be 7145529. Pat your back if you've got all the questions absolutely correct. You're really doing very good on playing with numbers. Now let's move on to the topic. Letters for digits. So in this section, we'll be solving some puzzles where some digits have been replaced with some letters. We need to break the code and we need to get to the answer that which letter represents which digit. Before trying some questions, let us discuss some rules there. Rule number 1. Each letter in the puzzle must stand for just one digit. So each digit must be represented by just one letter. Rule number 2. The first digit of a number cannot be 0. Thus, we write the number 73 as 73 using the 2 digits only and not as 073 or 0073. Let's come to some questions now. Question number 1. Find the digit p in the addition. So this is an addition problem for us and we need to work out the value of p. In such questions, we always start from the ones column and hence eventually we'll move to the rest of the columns to the left one by one. Now let's look at the ones column. P plus 1 is 8. We need to figure out what is p. So of course we know that 7 add 1 is 8. So we will be writing a little 7 over p just to keep in mind that we can fit a 7 in place of p. Because we've got some more p's in the question, we need to check that whether 7 is satisfying all the answers or not. Let's come to the tens column now. 2 add p is 9. And as we have already discussed that the value of p would be 7, so 2 add 7 would be 9, which is satisfying this condition as well. It means our answer is absolutely correct and we have broke the code and p here actually stands for 7. Let's try some more questions now. Come to question number 2. Find a and b in the addition. Question number 1. b5a plus 4ba. Remember, we need to start from the ones column and then to the tens and then we'll move to the hundreds. If you notice, in this question, we've got a very interesting thing. In the ones column, we need to add a digit to itself so that the answer remains the same. So if it is a at a is equal to a, we have only one digit in maths which gives the same answer on adding to itself, which is 0. So 0 add 0 is equal to 0. It means we have broke the code for letter A, which actually stands for 0 here. Let's move to the tens column now. 5 add b is 6. 5 add 1 is 6. So again, because we've got some more b's in the question, we'll write a little 1 over it and 5 add 1 is 6. So we are done with the tens column as well. We'll move to the hundreds column now. b add 4 is 5. So yes, 1 is satisfying that place as well. It means we have broke the code for b as well and the answer is b stands for 1. Let's try the second part now. 59b add 071, which is bb7. We'll start from the ones column again. So b add 1 is 7. We know that 6 add 1 is 7 So we'll be writing a little 6 there. And yes, we'll check the B for the other 6 as well. So 9 add 7 is equal to 16. But remember the rule that one letter represents one digit only. So 6 will come here and 1 will be carried forward. 5 add 1 add 0 is 6 again. So yes, it is satisfying all the places, and hence we broke the code for B as well. So B here stands for 6. Congratulations on working so hard with the letters. Let's come to the next section now, which is test for divisibility. If we talk about dividing the numbers by 10, we just need to keep in mind one thing, that the digit at the ones place has to be 0 always. So if the digit is 0 at the ones place, the number would always be divisible by 10 without leaving any remainder at all. That was the rule for dividing the numbers by 10. Let's come to the next one, which is divisibility 5. So again, we just need to keep in mind two things while we are trying to divide any number by 5. So the thing is that the digit at the ones place has to be either 5 or 0, as shown in the examples there. So if that digit is either 5 or 0, the number would be completely divisible by 5 without leaving any remainder at all. Let's come to the next rule, which is divisibility by 2. Again, we just need to keep in mind one thing, that the digit at the ones place here has to be an even number. So it can be either 2, 4, 6, 8 or 0. If that number is an even number, so the whole number would completely be divisible by 2 without leaving any remainder at all. Then we are left with two more rules, divisibility by 9 and 3. So the rule is same for both the numbers. If the sum of the digits is divisible by 9, the number would be divisible by 9 completely without leaving any remainder. Same goes for 3. If the sum of the digits of the number is divisible by 3, the number would be divisible by 3. So let's check the divisibility of this big number by 9. Let's see if it will leave any remainder at all or not. Now we've got some practice questions right here. You can pause the video and try all the questions one by one. Then we've got some more questions right here. After you're done, you can match your answers with this slide. Thank you for watching the video. For more, please log on to justtutors.com.